You bet. You go down. Okay. So to find the gradient, it's rise over run. And when you have the graph, you're simply going to count rise over run. So the steps for doing that is simply to choose two easy points. Now, sometimes they'll choose those points for you, and that's what you're going to see first. And then you're just simply going to count from one point to another, making sure you watch for the signs. Again, up is positive, right is positive, down is negative, left is negative. And always remember it's rise over run, and then simplify your fraction if it will. So let's look at this particular one. First thing we notice is that if you're reading this graph, going from right to left, which is the way we read things, right? If you'll notice, this graph is going upward if you go from right to left. Do you notice that? Yes. You hit it, and in order to follow it, you would have to go up, right? Now, not all lines will do that. Some of them could be going down. So when you hit it, you start going down. Okay? And if you know that piece of information, if you're going up or down, then you're going to already know what sign your slope should be, your gradient should be. If it's going up like this, if you hit it and start going up like that, that means automatically that your gradient is positive. So if you get a negative gradient for this, you'll know you're wrong. Yeah? So if the line is going up, when you hit it from again, you have to be going in the right direction, left to right. If the line makes you go up to follow it, then that means the gradient is always going to be a positive. Okay? So what you're going to do is you're simply going to count from one point to another. And they've given you some points. Now, first, before we talk about the points, I want to look at what I mean by easy points. The line consists of an infinite number of points, right? So there are lots and lots and lots of points. But easy points are like these that cross at intersections that make the numbers easy to read. And that's why we call them easy points, right? The values are very easy to read. Now, compared to, for example, say, this point. Can you tell me what that point is with complete 100% accuracy? No. The best you can do is just give an estimate of it based on where it's falling, right? Okay? So this one is not a point that you would want to choose. Do you see the logic there? So you're going to choose points that are easy to measure. So would that one be an easy one to measure? Yeah. Absolutely. It's 4, what? 8. Okay? Would this one be easy to measure? No, absolutely not. It would be some fraction. And the best you could do is estimate. And an estimate is not good enough when you're trying to get a value for the gradient, right? Not if we can use some other point that we give as the value. Mm-hmm.
So that would be would that be like 2.75?
Yeah, something like that. Yeah. Again, the best you could do would be just like you did an estimate. Okay? Now, you'll notice that they've already chosen a couple of points for you there. They've given you this point and this point. Now, those are not the only points you could use. You could use any points on the graph. Okay? So I could just have easily have used this point and this point. Every point on the graph will give you the exact same gradient because it slopes in a straight line. So the gradient is the same along the entire line, no matter where you are.
Is this just from linear though?
Okay? All right. So let's just use the points they have. What they're trying to do is the points they have are very far apart, but they're wanting to see that you reduce or simplify the fraction at the end. Okay? Now, to get from here to there, I have two choices. I could go down and then to the what? To the left. But down and left would both be what sign? Negative. Do you want to use negatives when you can avoid it? No, probably not. Okay? Instead, we could go to get from this point to this point. I could go up to that line, right? And then to the right to get to the point. Remember, when you're working on a graph, you always have to travel in straight lines, right, along these pieces. So if I'm going to go along this line of 7, I have to follow it, and then I can turn. Think about it like there are buildings in the middle. You can't go through the building, right? Okay? So when we're graphing. So let's just count those pieces from there to there. Well, every line is a unit, right? because we're doing units of 1 all the way up. Okay, so here we go. To get from here to there, first I've got to get up that point, right? Do you agree? That's 1, 2, 3, 4, 5, 6 units I had to go up, right? So I had to go up how many units?
6.
So that gives me my rise. Then from that point, I have to get that direction. How many units? 3 units. So that gives me my run. It's just a matter of counting. How many lines, how many units are you going across? And would I leave it as 6 over 3?
No.
Nope, the gradient would be what? 2. Now, if you wanted to write it as a fraction, you'd write it as 2 over 1, but we don't write 2 over 1 as normally. We would, to simplify it fully, we would write it as 2. Okay? Sorry, hold on. She had her hand up first. Yes?
How do you get the where do you get the 2 from?
6 divided by 3. Right? So we simplify the fraction. So it's 6 divided by 3. Remember, the fraction bar is always a division symbol. So if you can divide, you divide. If you can't divide, you reduce. If you can't do anything, you just leave it.
But then why'd you start the closet full instead of just coming like the 1?
Because that's the point they gave me.
What if?
It's like covered by the green.
Yeah. So, right, the purple dots is the ones they gave me. I could just as easily have started it here and gone to here, and I'd get exactly the same answer. Want to see it? To get from there to go up, yes. You go up how many units? 10. And to get from there to there, I'm going to go to the right. How many units? 5. And what's 10 divided by 5? It doesn't matter what points you choose. All you're going to be doing is counting from one to the other. Pardon me?
5 divided by 5 would be 1.
Mm-hmm. Okay. All right. So, let's look at another point. Say we have this point and this point. Should I expect exactly the same thing to happen?
Yes.
Absolutely. To get from that point to that point, we have to follow these dotted lines. So I need to go up 1, 2, 3, 4, 5, 6 units.
Yes.
And to the right, how many units? Oops, 3, which still gives me a gradient of 2. No matter where you are, the gradient will always be the same. The shortest one?
Yes.
On
this
2
one.
and 1.
2 over 1.
Well, yeah, or 0, you could do 0, 0 to that, which means you go up 2 and to the right 1, which is 2 over 1. You bet. So I wouldn't have chosen, normally I would not have chosen points so far apart, but they did it just so that you can see that you reduce the fraction or divide it. It doesn't matter. Okay? So usually if you're choosing these points, choose the ones that are the closest ones that are the easiest. And so this one goes through there and goes through there. Those are the closest easily identifiable points, yeah? You could do from here to there, but it looks like 1/2, but am I guaranteed that it's 1/2? No. And besides, do you want to divide with fractions? Probably not. Most people don't. Yeah. Okay. So, all right. So does it matter what points you choose?
No.
Absolutely not. Okay. All right. Let's look at a few others just to make sure that we're all on the same page. It doesn't get changed. The method doesn't change. That's how easy it is. That's the way it's always going to be. Okay. So you see there, they went left, then up. I do not want you doing that because it gives you the false impression that this should be first and that should be second. You always do it as rise over what? Run.
Not rise,
Okay?
rise.
If this is run over rise, and then they just expect you to know where to put the right numbers. That is not a good idea.
But you could.
Okay? Because then you'd have to put that at the bottom and that at the top. Doesn't make any sense. Right? So, okay?
Read left to
Yeah. Okay. So they're just trying to get you to discover that it's 6 divided by 3, but that's stupid because if you just did it as rise over run in the first place, you'd get 6 over 3. All right. Now, here they're showing that you could use it as smaller units, right? So here they're only 2 units apart, but I would have done this on this side and gone up 2 and what? To the right 1. Okay? Right? So here we go. This one, they're actually using time and distance. And what do you notice? As the time increases, what's happening to distance? It's increasing as well. And that's what's happening when you have a positive slope. This is a positive slope. That means as this one increases, this one will also increase. Does that make sense? So you're going to use some of these in terms. So let's calculate the gradient of this. Go.
Oh.
pick any points that you can read nicely and count rise over run. Come on, guys. Then we'll call on somebody to help us out.
I still don't get this at all.
No, you're making it harder than it is if you can't count. Caroline.
You can pick your own points, so when it crosses the
Okay.
two
Just find any points you want to use.
So basically, these are the
Okay.
points in this line.
Wait, it's up here. So
In order to find the rise of the run, you have to rise first. So you rise up to
I still on like a last one.
Just pick any 2 points. It's just you pick the points.
It's going across.
Okay. Got it? Tianyi, you want to help me out here? All right, so which 2 points did you choose?
Make it easy to get hold of.
Pardon?
They would find the point.
Can I pick this point? Oops, sorry. Can I pick this point?
Yeah.
Yeah, because it's easy. Could I pick this point? No, it's too hard to read. Could I pick this point? Absolutely. Okay. Now, could I have picked different points? Sure. But to get from here to here, Tiani, I had to go up how many units? 1. And then to the right, how many units? 2. And will 1/2 reduce? No. So the gradient is 1/2. And we always label it what letter? M. Just get in the habit of it. They're not going to ask you for it in your homework. They just want the number. But I want you to get familiar with that notation. We reserve the letter M. Who knows? We reserve the letter M for gradient or slope. Okay?
Yeah, why? Is that worth a thing?
Don't know. Look it up and see.
Why don't they do something else?
Cheese? Yeah, who knows?
Taken by like grams or something.
Okay.
Maybe someone thinks 1 gram. I don't know.
Who knows?
The gradient is 1 gram.
Okay? All right.
The gram.
Let's look at another, guys. Okay, so you see, now they picked different points and they used run over rise, which makes me insane, but it doesn't matter. Just as long as you pick any 2 easy points, they went up 1 and to the right 2. Yeah? Up and right, not along. Okay? You can say rise and run, but don't say over or across. Okay? Which means that for every 1 second he walks, he goes 1/2 meter. All right? Okay. So we'll talk about the meanings of those as we go. Okay, here we go. So if you look at this one, so if he had gone 8 from 2 seconds to 10 seconds, that's 4 over 8, which is still what? 4 over 8, which is still 1/2. Sorry. Fell in the trap of listening to their stupid thing. Go in the wrong one. Okay?
Time for you to have it go.
We just had to go. Now, what about if they're negative? You're just going to still count. Ugh, I hate it that they count backwards. I don't like theirs. Hold on. Let's see if they'll give us a blank one.
Can we do one where it would be negative?
Yeah, that's what we're looking at. Okay, here we go. All right, first of all, I know the gradient of this line is going to be negative. Why? You bet. If you were walking along from the left and hit the line, you would have to start going down to follow it, right?
Like it's a straight.
Okay? Exactly. All right, so let's say, well,
No, like it's like a.
in Wellington, yes, often streets turn into, your street turns into frickin' stairs. All right, here we go. Let's say frickin' Prince Street.
Oh, right, yeah.
Did you forget what street you live
I
on?
was like, wait, what?
What?
Poppy
Wait,
Street.
Mrs. How do you know where Poppy lives?
Stalking all of you. No, come on. No,
He
because,
lives on the street over from me.
yeah. All right, here we go. We're going to go from these 2 points. Could I have used different points? Doesn't matter what points I use. Do you want to use some that are farther apart or closer together? What do you want to do? Well, those are the closest as you can get, right? Do you see that? Okay. Yes, because the others don't cross at an intersection. So to get from there to there, I need to go up. How many?
Rise, 1, 2, 3.
1, 2, 3. And then to the what? To the left, how many units? So 2 units, and left 2 makes it a negative 2. Okay? So it's going to be 3 over negative 2. Is that my finished answer? No, because I need to simplify it. Positive divided by negative makes the whole fraction what? Negative 3 over 2.
I live right next to
Okay? All right. Now again, You could have used different points. It makes no difference. We could have chosen this point and this point. We just would have had to count more. To get from there to there, we have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Up 9. Then to the left, 1, 2, 3, 4, 5, 6 units. This is negative 6. Positive divided by negative is negative. 9 won't divide by 6, but they'll both divide by what? 3. So that's going to give you 3 over 2. So do you see that it doesn't matter where you count from. It's always going to be the same number, same value.
Thank you.
You're so welcome. Anytime. I don't know what I did, but I'm happy that I did it. If it makes you happy, then it makes me
You don't
happy.
really have a choice. This is kind of your job.
Yeah.
Oh, I have a choice. You've never had a bad math teacher?
Yes.
Yeah.
I could have said, okay, read this, learn it.
All my math teachers are really nice.
You've had some good ones.
What the hell?
Mr. Kavanaugh was excellent. You had him last year, didn't you? Didn't you? I thought you had Kavanaugh last
Oh,
time.
no, I had Miss Mill.
Oh, Miss Milne, she's good.
She was like so cheating.
I was so scared.
What now?
She was not like a good teacher in my opinion. Yeah, like I feel bad, but like then again I feel like he was a great teacher. Like he was nice, but he just
He really cared and he knows his material, but yeah, it's hard. He had a difficult time relating to people.
So on his last day,
He was
he made the entire class origami love heart
It was
with
so
our names on
Yeah,
there.
he was super nice, but
I
he was
just
like
have-
I don't know. And he was also our form teacher. So.
Yeah, he's our form teacher.
I was on
Having a math teacher.
Okay, guys.
I didn't have to take, except I got really scared of him because I passed his class all the time and he was screaming at class like, why can't you just listen? What do you not understand?
That was probably our class. He said that to us like a couple
And
of
I got
times.
so scared when I was passing by because he was just like screaming and screaming.
Oh,
And I was like, oh my god.
Yeah. I don't know.
All right, you've got a homework assignment up. So do some counting. You should be able to get this one done completely before the class ends. If you use your time wisely. All right?
But I really like his milk.
Oh yeah.
And then